Hello, everyone. Good afternoon, the authors and invited guests. Welcome to Technical Session 7C. Myself, Ishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information Communication Technology for International Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 5th and 6th of April 2025. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to the chair for this session. We have with us Ma'am Kahina Amara, who is a senior researcher at the Center of Development of Advanced Technologies, CDTA, Algeria. Her main research interests include augmented and virtual reality, 3D interaction, affective computing, computer vision, emotion recognition, and healthcare. We welcome you, ma'am. We also have with us. Good afternoon, ma'am. We also have with us a session chair, Dr. Dushyant Singh Rathod, who is an esteemed professional currently serving as a professor and head of Department in Computer Engineering at Ahmedabad Institute of Technology. He brings a wealth of academic expertise to his role, accumulating 11 years of dedicated teaching experience. Dr. Rathod complements his academic achievements with a robust industrial background, boasting 4.2 years of valuable industry experience. We welcome you, sir. Now, I'd like to get started with the paper presentations. Our first paper presenter for the session, Pachika Vineet, with their paper titled Empirical Study on Data-Driven Hybrid Recommendation System for Trip and Itinerary Planning Using Semantic Approach. Sir, if you're ready, then you may go ahead.
Yes, I'm ready. I can go ahead. Can I share the screen?
Yeah, sir. Please go ahead.
Is my screen visible now?
Yes, sir. It is visible.
The paper is Empirical Study on Data-Driven Hybrid Economic System for Trip and Itinerary Planning Using Semantic Approach. So before moving into abstract, the main idea of this paper is the idea is to propose a recommended system using non-traditional data rather than reviews from TripAdvisor and Make My Trip, and semantic that curates itineraries for user based on their preferences, personalized solely to them. So what they're trying to say is using data sources other than the reviews of TripAdvisor, Make My Trip, and Clear Trip, we can use other data sources that are more richer than those reviews, and then we can use them to personalize itineraries for the users. So abstract. So by the way, itineraries increase day by day, and the YouTube content is also growing day by day. So the data, what we're taking is from YouTube blogs. The idea is to take the data from YouTube blogs because content creation is getting richer and richer day by day. So for example, if you take any place around the world, irrespective of the country or any place, uh, there are many videos present across the YouTube so that we can know hidden gems, cultural insights, and other places so that we tend to attend them. If we see, many people are nowadays only preferring YouTube vlogs because they want to enjoy the place both culturally and in adventure way. The main idea occurs from that. So for that, we have already researched some of the papers. For example, if we take a paper, data-driven methodology for knowledge, which is developed by French professors, in this, they used ontology approach, but it is only limited to Paris region. So the review formula used is given below, where the f of g of t is already the geographical constants they have located. So basically, the idea is already they are only implemented only to Paris region. Our idea is to more expand the demographic regions. And in one of the papers, this is a paper, context aware recommender system. This is purely based on reviews of TripAdvisor, uh, where BU and BA are some of the aspects that are conditioning the reviews. So if we see from these papers, many of the papers are Yelp datasets, TripAdvisor, and also use some of the datasets like ClearTrip dataset, where the reviews are taken. So, for example, if we take, yeah, this is under a paper like personalized itinerary recommendation with time using GPS datasets. GPS datasets allows, but it doesn't allow much content like YouTube. So, but only this is only restricted to time constraint of the place. For suppose if you are traveling in a place for about 5 hours or 6 hours, then the time constraints of each place, so how much time should be spent at each place, is shown by this paper. So what we are trying to do is, these are different papers, so we are trying to propose a system where all these ideas are incorporated. These are some of the insights that you have taken from the system, like some collaborative filtering models face data scarcity because there is no much data other than traditional data, and GPS based system only offer time constraints, but not a contextual depth for user generated content. So major research gaps are demographic expansion, by addressing the cold start issue by social network. Demographic data is nothing but the location data, and then integration of contextual factors. So some of the factors like traffic, weather, because when we go plan a trip, we also plan what is the weather, so that we can choose what we like to wear. And also traffic is just to for a time constraint. And then the main important part is multi-user and group based recommendations. If you see many papers, they are solely based on single user but different constraints. So if you try to take multi-user recommendations, so if two users are going to the same place, but there's itineraries also matching to a similar way, so why don't we just use recommendation techniques to recommend a similar itineraries to the other user? This is one of the idea. Next one is culture insensitivity. This is the main gap we found out, because in reviews that are of traditional websites like Make My Trip, Clear Trip, etc., there is no cultural importance, because in YouTube vlogs we know vloggers will take cultural importance to a higher scale by just the local traditions or the local festivals. They show entire thing in the YouTube. From these gaps, we propose some of the objectives. So, like successful extraction of data from logs and blogs. Like for YouTube, we can use YouTube API to extract the logs, transcripts, or we can use audio to text. And then we can apply semantic approach and to create a knowledge base based on those transcripts what we have extracted. And then we build a recommendation system by creating a knowledge base using those transcripts. So user behavior also is important here. So let the user input be like, I want to go to so and so place in 3 days under a budget of 10,000. So example, if we take like that, we have to extract the user behavior from that, and then we have to generate inferences from the knowledge base, so that we can give a personalized itinerary for the user. And the main important part is weather integration. Weather integration is necessary because user needs to know what kind of clothes he need to wear when he wants to travel to such place. And this is one of the proposed system architecture that we would like to show, where the knowledge base here, knowledge base is generated from the YouTube vlog transcripts of different places. Uh, Better take many vlogs for each place and then select a better vlog. Then in a user interface, the input provided by user is undergone semantic analysis, and then we go to the knowledge base. In knowledge base, the user behavior is mapped to the knowledge base, and we get the recommendation. Here, the recommendation is of two types. One is semantic matching from the knowledge base. Other one is collaborative filtering to compare the similar users. Then we get a perfect itinerary. Then feedback will be provided by user to the saved itinerary. So this is a continuous loop is proposed by our paper. Thank you. Any questions? Hello. Hello.
Ma'am, sir, would you like to ask any question? It seems we do not have any question. Thank you, sir. We'll be proceeding with our next paper presentation. I'd like to invite paper presenter Sachin Singh with the paper titled Enabling Sustainable 5G Networks Through Energy Efficient Open Radio Access Networks Ecosystems. So if you're ready, then you may go ahead.
Yep. Just give me a second. I'm sharing my screen.
Sure, sir.
Okay. I hope my screen is visible.
Yes, sir, it is visible.
Thank you very much. So good afternoon, everyone. Today's topic for my presentation would be enabling sustainable 5G networks through energy efficient open radio access network. Basically, to begin with, first of all, a brief introduction regarding the Open RAN 5G networks. As we all use mobile phones, in the legacy network, what happened is that we started with 2G, which is GSM, then moved to 3G, then 4G, and now 5G. In 5G, basically, what we are trying to do is that we are coming up with a new technology, which is called Open Radio Access Network. Here, what we are trying to do is that in the legacy network, like, operators used to stick with one particular vendor. So let's say if they are working with Nokia, they have to stick with Nokia for their air interface, which is UE to BTS, and then to BSC, and then to MSC. That means their core network, their radio network, and basically all the equipment needs to be from the same vendor. So it's kind of a monopoly which used to happen in the past. Whereas in nowadays, what is happening? I mean, the big change that has come with 5G Open Radio Access Network is that now the operators have that independency where they can go with any of the network. When I say any of the network, that means they can have the array interface with one network, with one vendor, and then let's say if they want to have their AWS cloud environment with a different vendor, they can go with that. So that's called the distribution radio access network system. So that's one of the main benefit of having the open radio access network. Apart from other benefits, I mean, this is just a high level benefit which I just mentioned. If we talk about the other benefits that is coming up with our 5G open radio access network, is also about the throughput and the call quality. When we talk about the throughput, let's say, let's go a little bit on the, the throughput output also, because in 4G, let's say, in your, I think you all are using mobile phones where your phone is latched either with 4G or 5G network. Even if I talk about the latest trend, I believe most of the countries have now started to move to the 5G technologies. Some of the countries which have now not been able to move to 5G, there are other challenges, and I think the primary challenges could be related to either the cost or maybe some other restrictions related to government. When I say government, that means either they need to have particular bandwidth available, because they cannot use any particular band on the 5G network. So unless their country provides the ecosystem that can support the 5G environment, they cannot deploy even if they have the right monetary system. So that's what I was trying to say regarding that, the challenges to deploy 5G ecosystem in their country. But coming to the benefit, I think in the uplink, ever, let's say if you are using as usual in a very layman language, if I have to explain, if you are planning to download a video, I think in the legacy network like 3G and 4G, I'm still using legacy network for 4G because, as I said in the beginning, that uh, because now most of the countries have moved towards 5G, so 4G has now kind of become the obsolete, not obsolete, but the legacy network. So the download speed as compared to 4G, 5G you get like maybe around in gigabits also rather than in megabytes. So that's one of the main difference that 5G Open Radio Access Network provides you, and also it gives you the from operator's point of view, it gives you the flexibility, to have all the equipments, to have all the data on the AWS cloud rather than keeping it somewhere in the local storage system, which can be, not a sustainable model in current world. So that's one of the other benefits that we, provide with 5G Open Radio Access Network. Regarding the architecture, I think I have already explained in the beginning that you know uh, the big shift that has come from 4G to 5G is from having a hardware dependency versus everything coming in the cloud system. That's one of the main architectural change that has come with the 5G radio access network. Then talking about the three key units in the 5G Open Radio Access Network, which is the distribution unit, which manages all the RF processing and the user data. Then comes to the second unit, which is called CU, control unit. Mainly, it is a BBU, baseband unit. And then the final is the radio
Excuse
unit,
me,
which
sir.
handles the RF data reception. Yes, ma'am.
I'm really sorry to disturb you, but could you put the presentation in presentation mode, full
Oh,
screen?
I'm so sorry. Yeah, yeah, I think I shared the wrong screen. Yeah.
It's all right. It's perfect now. Go
Thank you
ahead.
very much.
Yeah.
No, thank you for pointing it out. Um, now talking about the two main categories, one is a non-real time and the other one is a near real time. Basically without going into much of the technicalities, all I can say is that, in the non-real time, it can handle the long-term network optimization versus managing the real-time network adjustment. Basically, it what we are trying to do here is to manage the KPIs, because, let's say if you have to do some changes in the network, depending upon the KPIs, let's say, your call drop rate is high, so how fast you can improve that call drop rate. So whether you can improve in a real time or you can improve based on the optimization results, because optimization results might take some time. So it could be like over the period of 24 hours versus real time, which can provide you the data immediately and then you implement the changes. So these are the things that differentiate between the non-real time and the real time. Now, considering the time that is allocated to us, I'll quickly move into the final part, which is the energy efficiency in the 5G with sustainable O-RAN ecosystem. I think other one of the main benefit, if I talk about, is about the resource allocation, planning and deployment, and the hardware solution. Hardware solution part, again, I have already discussed in the beginning. One of the other thing, which is one of the key benefit considering the energy usage in most of the ecosystem, a 5G ecosystem, is the energy harvesting and transfer, where we are using the renewable energy source such as solar, wind, or maybe the airborne radio communication. Um, with that, I think my conclusion would be that in current world where the data requirement has become such a high sustainable requirement, I think we have to move towards an ecosystem which can provide you much faster data rate and with reliability and the security. So with that, I believe that 5G O-RAN ecosystem is the perfect solution in current scenario. And very soon, probably in next 1 to 2 year, the world will see that how we are moving from 5G O-RAN to 6G, and then we can discuss about the other pros and cons of the 6G ecosystem. With that, I rest my case. Thank you very much for the time. I appreciate it. Goodbye. Any questions? I'm ready to take.
So, ma'am, would you like to ask any questions? Seems
Okay.
we do
If
not
not,
have any questions.
thank you very much for the time.
Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Gurneet Singh with the paper titled Fine-Tuning and Efficient Quantization for Optimization of Diffusion Models. So if you're ready, then you may go ahead.
Yes, please let me share the screen.
Sure, sir.
Let me know once it's visible.
Yes, sir, it is visible now.
Okay. So good afternoon, good evening, everyone. My name is Gurneet Singh, and I'm here to present my paper on fine-tuning and efficient quantization for optimization of diffusion models. So our paper ID is 371, and I am the primary author, and I come from lovely professional university. So in this paper, we have multiple things that we are going to do about diffusion models. So starting with the introduction, first of all, we see that the diffusion models, basically the part of generative AI, they have been getting a lot of attention recently nowadays, and their achievement is their progress actually. So from starting with basic translators, we now have image generators. You can easily generate any image using the text. And the thing is, these are very good. They give you a lot of results, but on the other hand, their computational requirements are also uh, very high. So if you are running a similar model on your local machine, you would fail to do so because they require a lot of GPU performance. So fine-tuning and training and inferencing, all of these require a substantial amount of resources. And for smaller organizations which are starting to work in the domain, they face a lot of challenge in gathering the total resources for these things. So for this, our problem statement arises is how can we fine-tune a diffusion model efficiently while preserving model performance and minimizing the resource usage. Our main goal for this research was that we can develop an efficient pipeline which combines fine-tuning, optimization, and other diffusion methods proposed in the past and create a single pipeline which can save us a lot of resources. For sub-objectives, it was to reduce the fine-tuning cost, improve the domain knowledge of diffusion models because the diffusion models uh, that are trained on the first level, they have knowledge of all domain, but if we need to give them specific domain knowledge, which if we want them to master a specific art type or text type, then we have to give them more kind of such data. Also, improving efficiency while combining different optimization techniques and evaluating the model consumption, resource consumption of generated model by the pipeline against the vanilla models. So for vanilla models, we mean that the models which are generated by the community, which are generated by some organizations and are open source to us. Coming back to the background of diffusion models, it started in 2015 when Sohel Dickinson introduced diffusion probabilistic models. So for those who don't know, diffusion models work on similar physics theory of diffusion. So basically you are generating something out of nothing, and this is done by giving them certain parameters, certain mathematical formulas. In 2019, Song and Anmon proposed a score-based generative models. So it's kind of a reinforcement learning where if the model is generating good images, you give it a score. If it's generating bad images, you give it a negative score, and that's how the model used to learn. In 2021, during the COVID time, OpenAI unveiled DALL-E, Fogview, and Nuva were also released. These were some of the most prominent image generating diffusion models that we have seen till date. In 2022, Stable Diffusion was also released. It is one of the most widely used open source diffusion models. And in 2023, Q-Diffusion introduced quantization techniques. So for first timers, quantization is basically like, so we have models trained in 32-bit or 16-bit numbers, right? So in quantization, we reduce the size of these bits to 8-bit, 4-bit, and due to this, the model size decreases, but also it causes a lot of performance in the model. Coming to the resource consumption of diffusion models, in this table, we have given some slightly publicly open data to us. So for stable diffusion 1.4, it used 150,000 GPU hours on a 256A100S GPUs, and it resulted in an estimated training cost of $600,000. So if you can see this table, then you see this that the training cost of any diffusion model is very high. You need a huge amount of GPUs, you need to invest a huge amount of time, and you also have to invest a huge amount of research and development at the back end. And this can take up to millions and millions of dollars for each of these models. Also, there have been certain techniques that have been proposed in the past. One is the low rank adaptation adapters. So what it does, it instead of training the whole models, we inject some trainable layers, which are basically new layers added into the already trained neural networks, and then you can train these specific layers. But a disadvantage of this is it's hard to inject new knowledge into these new layers, because that will create some sort of bias. And also they have quantization methods that I have already told. That is also always a trade-off between model size and the results. We can reduce a model size from float 32 or float 16 to float 16 int 8 or int 4. There is also dynamic quantization technique, which is only during the inference phase. So when the model is loaded onto a GPU, we can quantize it on the go, and then we can generate the results. For a dataset use, we used a realistic face images dataset because, as I've already told, we wanted to improve the domain knowledge of the diffusion model. We selected stable diffusion 1.4 as our base model, and we noticed that it was not good in generating realistic images. So we gave it a dataset which has realistic images and some captions with that. So you can see the captions are very generalized caption. We are not mentioning the name of the person, but also we are mentioning some of the objects, some of the face structure, some of the expressions, items, gender of the user in the image. So it's a very generalized data set, and it can help model to learn about specific objects in the images. So our proposed methodology is, first we fine tune the model onto its original bits to improve the domain knowledge. This can be done really quickly. We did it for 1,000 steps and it was already giving us good results. Then we can add more adapters to it to fine tune and improve its performance. Then during the fine tuning also, we gave it an FP16 quantization if it was in the FP32. Then dynamic 8-bit quantization during the inference. After that, we made sure that the images that were generated were of 256 by 256 resolution, because we don't want to invest too much resources in generating high quality images, because we had a separate pipeline after this, which is an image upscaler, which can upscale the images from 256 to an HD resolution image. This is the proposed pipeline that we have used. So in this, you can see that we have an input text and we have a noisy image that we give it as an input to the diffusion model. Then it generates an images in 256 resolution. It was a fine-tuned model with a LoRa adapter at the front and FP16 quantized model also. And the 256 by 256 resolution image then goes back to the stable diffusion upscaler image, which generates images in an HD resolution. And this whole pipeline, when running on the inference, was using dynamic 8-bit quantization. So we were saving a lot of resources during that as well. We tested a lot of parameters for this pipeline because we wanted to make sure that resource consumption was less, and also the images were generated of good quality, were more relevant to the context given, and also the time taken was also less. So the following parameters were tested during the whole training phase, that is image resolution, augmentation steps. So augmentation is basically how we are giving a single image in multiple different ways so that it understands the image more. It can be rotating the image, it can be changing the coloring of the image, changing the structure of the image. And then we have training steps, epochs, batch size, learning rate, maximum gradient normalization, warming up steps, and learning rate scheduler. These are some of the images that were generated in an HD resolution after the upscaling. So you can see that even for some images like the last one in the cowboy image, we can see that the realism has been improved as we compare it to the vanilla model. And also the context that were given, the model is able to learn the context more and is able to give us good results. Coming down to the inference time and the resource utilization, which was the main point of this whole pipeline, we tested it on a Google Colab free tier, and it took a very less time for 10 guidance steps. So it was 1.42 second for 10 guidance step to generate a single image. And as compared to the memory utilization, it was 3.5 GB, which is half the total memory taken by the raw vanilla models. So this model performs well, takes less time, and also gives us good result on the same at the same time. Coming down to the training loss, we noticed that we achieve a good stability after 1,000 steps, and we use this smooth it using moving average formula, so that we came to understand that yes, after 1,000 steps we are having good results, and after 1,000 it seems to overfit on the data. Coming down to the conclusion, we say that the combining low rank adaptation metrics, dynamic quantization, and upscaling for the same pipeline is an improved efficiency and quality performance. And then this pipeline also preserves the generative fidelity while minimizing latency and memory usage. Some applications can be using the diffusion models at real world applications and in a constrained computational requirement. So for example, I'm using this on my personal desktop, then I will be able to execute the whole model. And the advancement can be that we push the boundaries of generative AI, especially for image synthesis in a constrained environment. Future scope. Adaptability, we expand the optimization technique to video synthesis and 3D content creation. We are looking forward into this as well. Then hybrid models, we can combine the previous traditional models which were used for image generations like GAN for enhanced generative outcomes. And quantization advances, that we explore a hardware aware and mixed precision quantization for edge device development. So edge devices are basically devices which are very close to me and away from the server. It can be your phone, it can be your router, it can be your TV also. So we can use these devices also for such purpose. Thank you. And if you have any question, we can discuss it.
Hello.
Hello, sir.
Uh, Hi, Gunit Singh.
Yes, sir.
It is a nice presentation.
Thank you.
Okay, but what kind of model? I think that you have created a hybrid model. So which are the models that you have combined and you will get the result?
Sir, we started with the stable diffusion 1.4 as our base model. And then we performed quantization steps onto it. We added some LoRa adapters onto it as well. And then we got our own, we can say, dynamic model, which we again quantized during the inference. So that's what we did.
Okay, so can you tell me the applications of your research?
Yes, sir. So for like like I've already showed, the resource consumption was less, right? And if we're talking about the resources, then recently OpenAI also released image generation in its own thing, and Sam Altman tweeted that the GPUs were melting because of so high resource usage by the users. So the best application that I can think of is we can replace bigger models with these smaller models to make it publicly available for users, and also for organizations who are stepping into this domain for the first time, they will have to invest less in terms of resources to get started with their technologies.
Okay, so now which tool that you have used for implementation?
Sir, for whole of the training, we used PyTorch, Accelerate library, and also Transformers library from Hugging Face. And then for the whole pipeline, we basically wrote a function which loads the model, and then for the inference converts it into the dynamic 8-bit quantization.
Mm. Okay, nice. I'm done.
Thank you.
Thank you, sir. We'll be proceeding with our next paper presenter. We have with us S.G. Vasudeva with the paper titled Forecasting Future Water Requirements and Assessing Storage Capacities in Reservoirs. Sir, if you're ready, then you may go ahead.
Yes, please.
Sir Vasudeva? Or if anyone's going to present on his behalf. Seems we do not have him. We'll be proceeding with the next paper presenter in the meantime. Amruta Khanaj with the paper titled Measurement of the Effects of Stack Overflow Code Snippet Evolution on Open Source Software Security. Ma'am, if you're ready, then you may go ahead.
Yeah, hi.
Yeah,
Yeah, I will start the presentation.
sure, ma'am.
Is my screen visible?
Yes, ma'am, it is visible.
Yeah, thank you. Yeah, hi everyone. So I'm going to present my topic. So this is a measurement of the effects of Stack Overflow code snippet evaluation on the open source software security. So usually, this study investigates the security implications of reusing code snippets of Stack Overflow in open source software projects. So we are presenting here the novel framework that proactively identifies and mitigates the security risks associated with the outdated Stack Overflow code snippets. So our approach combines the static code analysis techniques and the continuous tracking tracking of the Stack Overflow post changes. And here, we are going to demonstrate the effectiveness of our framework in detecting the potential vulnerabilities, and then after alerting to the developers about the security relevant updates in the reuser codes. So this research introduces the automated system to track and the notify developers about the outdated code snippets. Then, coming to the background and the related work regarding this topic. So prior studies shows that many Stack Overflow code snippets contain the vulnerabilities such as the improper API usage, then dependencies, then weak cryptographic practices, so which can lead to the security threats in the open source projects. So one of the fundamental concern regarding this software security is ensuring that reuse code does not introduce the vulnerabilities due to the outdated implementations. So this research has shown that a significant percentage of the Stack Overflow snippets, which contains the security weaknesses such as the improper input validation, then weak cryptographic practices. So to address this issue, machine learning and the automation techniques have been explored, and clone detection and natural NLP models have been employed here. And then overflow for updates and notify developers when their reuse snippets become outdated or insecure. So to address this challenge, this research focuses on implementing an outdated notification system that alerts developers when they reuse code snippets from the Stack Overflow which became the outdated. Coming to the methodology, this system identifies reuse Stack Overflow snippets in the GitHub repositories using the abstract syntax tree analysis and the cosine similarity techniques. And after that, we are going to do the analysis for security patches. So here, a security detection model powered by CodeQL examines updated snippets for the secure vulnerabilities and then classifies these updates using the NLP based commit message analysis. Then after, we are going to do the notification and monitoring. So this system sends the automated alerts via email and the GitHub issues when the outdated snippets are detected. And then after, a structured pipeline integrates data collection, code analysis, and similarity detection. And then at the end, we are going to do the mitigation of vulnerabilities in reuse snippets. Then coming to the flow chart. So firstly, this model is the system initially fetches the code snippets from the Stack Overflow. Then we are going to analyze and detect the which outdated codes are present there. Then after, we are checking with the security risk. So if there is any outdated code available, then we are going to update that in our code base. And if that is completed, then after we are generating the alert and notifying the developers. So this process continues. Then after, we are coming to the results. Then here in the results section, if you check the precision of the this system, then it's like about the 95%. And if we check the FI score, then it is the 91.6%. So while the system is successfully improves the security, so developer response this challenges the reliance of the Stack Overflow updates. And then if you check the benefits of this system, so it prevents the security breaches, reducing the financial and reputational damages. Then it also improves the overall software reliability and security and reduces the need for the costly post release patches. If you check for the limitations, then this system assumes that the security related edits are always reflected in the Stack Overflow post, which may not be the always same case. So to improve this one, so we can extend this model for monitoring to security advisories and CVS databases to capture the broader security risk. And then in the conclusion we can conclude like the use of code snippets from Stack Overflow in the software development offers the significant benefits in terms of productivity and quick access to problem solving solutions. Our analysis reveals that while Stack Overflow snippets frequently evolve, updates are often not propagated to the GitHub projects, increasing the risk of the outdated and vulnerable code being used in the real world applications. So, this study highlights the need for continuous tracking of reused code to mitigate the security risk. And if we go for the future scope of this one, then we can analyze this like how the code snippets evolve across different platforms beyond the Stack Overflow and the GitHub. So yeah, I'm done with the presentations. If we have any questions, like we can discuss.
So, would you like to ask any question?
Please go to your title, please.
Sorry, sir.
Please go to with your title. Can you
Okay.
show me your first slide?
Yeah.
Okay. So are you going to overcome the software security through your research?
Like completely we can't say, but it's a bit of we are doing that thing, because like sir, previous work which is done is they are just identifying this outdated codes, but after that we are we are doing the additional thing is like we are identifying the outdated codes, and then after we are comparing that uh, whether those outdated codes are present in our GitHub code bases or not. And then if that detection is found, then we are sending the alerts to the developers as well. So
Okay.
with
So
this
what is
like
okay? So what about your contribution in your research?
yeah, so the this I have completed the detection part, this analysis part, and then the alerting things as well I have completed. So in the last stage, alerting stage, we are sending the notification to the developers. So this we are reducing the security risk. So if suppose previously any developer is going to check the if whether in his or her code base any outdated code present or not, so it can take the long time. So with our notification system it will be reduced to 2-3 days. So within that 2-3 days he will get the notification and he will check and update his code base.
Okay, I'm done.
Yeah, thank you.
Thank you,
Any
sir.
other
Thank you,
questions?
ma'am.
Yeah, thanks.
We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Prakhar Chaturvedi with the paper titled Novel Low Power SRAM Cells in 16 nm CMOS Technology. So if you're ready, then you may go ahead.
Yes, ma'am. So, good afternoon, everybody. My name is Prakhar Chaturvedi, and today I'll be presenting our work on novel low power SRAM cell in 16 nanometer CMOS technology. This will be the presentation outline. We'll begin with the discussion about SRAM, and we'll also talk about our proposed SRAM architecture. Then we'll see about sense amplifier. This is sense amplifier circuit is used in reading operation during the SRAM, and we'll have a simulation that we have done in ICTIS simulator, and we'll compare the results with a conventional 60 SRAM cell, and then we'll move on to conclusion and references. Now, if we talk about SRAM, SRAM is used for high-speed applications. It is primarily used in cache memories in CPUs and GPUs with the requirement of energy-efficient designs for optimized performance. SRAM demands are continuously increasing. SRAM designs also have a versatility provided they provide a fault-tolerant as well as attack resistance design. Now, our work is mainly based on the how do we reduce the SRAM operational power. Now, SRAM power consumption can be broken down into two main categories. The one is active power, also known as dynamic power. It is the power consumed when the SRAM is actively switching. That is, either we are reading or writing into the SRAM cell. Whereas the standby power or the leakage power refers to the power which is consumed when the cell is in the hold state. That means the SRAM cell is retaining its data. Now, if you look at the conventional 60 SRAM cell, it consists of a two CMOS inverter connected back to back, and also two access transistor. You can see in this image, M3 and M4 are provided for access. When the word line is activated, the transistors connected to the SRAM cell provides the data access through this bit line and bit line bar. Now, this is our first proposed SRAM architecture. In this architecture, you can see we have the 60 SRAM cell, but we have added three new transistors, the M7 transistor, M8 transistor, and the M9 transistor, which act as a MOS capacitor. During normal read and write operation, the word line is on, which is used to provide the discharge path through this M7 transistor to this M9 capacitor. But whereas during the hold operation, the word line is off, which means this M7 transistor is off. So what happens is the cell does not experiences full VDD potential difference across the cell itself. At node N1 there is a charge there is an increase in charge due to charge sharing because of M1 and M2 NMOS capacitor, and this N1 node is connected to this M8 transistor which gets turned on as the N1 voltage rises. Now the charge that was stored during this M9 during read and write operation get successfully discharged to the ground through M8 transistor. The key advantages that we were able to figure out was extremely low operational power. The leakage power got reduced significantly, that we'll see in the upcoming slides about the results. Also, write stability was also improved. Now, this is the second architecture that we have designed. You can see an external circuitry is provided. This is known as the B-out external signal. This architecture uses the phenomena called body bias effect. The body bias effect enables to control the threshold of the MOSFET by changing by applying the terminal either at source or the body. So during the normal read and write operation, when word line is high, so the cell gets a discharge path through this M7 transistor, whereas during the hold operation, the VDD minus 2, due to these two pass transistors, VDD minus 2 VT threshold drop is applied at the at this N1 node. So during hold operation, instead of entire VDD across the potential VDD voltage, a lesser voltage appears across during the hold states. So less potential difference means less leakage power, which consequently leads to less leakage power. The third architecture takes the first architecture. You can see the third architecture is an enhanced version of first architecture, with the lower portion is similar to the first architecture, but we have also applied power gating at the top of the pull up transistors. During the read operation or write operation, this word line bar, which is the inversion signal of word line, is provided such that the full VDD appears across this PMOS transistors. But during hold state, word line bar is active, so VDD minus 1 VT threshold drop is due to the pass transistor action of M10 transistor appears across the SRAM at the top of the SRAM cell, whereas similar action that we have discussed in the architecture A1 instead of ground path, that there is some node voltage N1 appear across at the bottom of the SRAM cell. So again, significant leakage reduction in power is observed. Also, improved write stability is also observed. These are the sizing of transistor that we took during the SRAM cell. M1 to M6 consist of the transistor cell of the conventional 60 SRAM cells, whereas M7 to M27 are the sizing that we have used in our proposed designs. The sense, okay, we'll talk about sense amplifier. The sense amplifier circuit is essential in reading, is essential during the read operation. Its function is to amplify small differential voltage that develops on the bit line during read access and translate into full digital output swings. These are the simulation results that we plotted via LT-SPICE simulation. We held a write operation for 5 microsecond, then again hold operation for 13 microsecond, then again a read operation for 5 microsecond, and a hold operation for 13 microsecond. And we repeated this cycle cycle of duration 36 microsecond for a simulation time period of 300 microseconds. All the three architectures waveform were verified and found out to be correct. Now, if we look at the average operational power consumption compared to the conventional 60 SRAM cell, there is a massive power reduction, about 70% power reduction on all the three proposed SRAM cell compared to the conventional 60 SRAM cell. This table shows the leakage current power as well as the leakage power consumption of conventional 60 cell and the proposed architecture. As you can see, the conventional 60 leakage power in picowatts is 337 picowatts, whereas for all the three architecture, the power is much reduced. This is due to the fact that less voltage is appearing across the cell during the hold state. This is the table that denotes the read and write delay of the conventional 60 SRAM cell and the proposed cells. You can see the write delay is more or less the same, but the read delay is increased because the number of transistors have been increased. These are the plots that we plotted for the noise margin. The first plot denotes write static noise margin. The second one is for the read static noise margin. And the third one is for the hold static noise margin. These three plots are
Excuse me,
for
sir.
architecture A1.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Okay, so these are the noise margin comparisons for all the proposed architecture. The read static noise margin of all the three architectures were nearly the same. Also, the write static noise margin of the three architectures compared to the conventional 60 SRAM cell is also a bit better. The only trade-off for lower power that we were observed was the hold static noise margin got decreased because less voltage was appears across the cell during the hold state. So we further had a for practical variation we compared we did a simulation for voltage fluctuation from plus minus 5% in A1 architecture. It didn't showed any variation. Also for the temperature we did a simulation for 0 degree centigrade to 70 degree centigrade. That also didn't showed any variation, thus further proving the robustness of the proposed SRAM cells. These were the conclusions. All the three SRAM cells were able to achieve less leakage power, thus obtaining less operational power. The write delays were more or less the same. The only trade-off for lower power was that the hold static noise margin got reduced as reduced voltage supply was appearing across the cell. Thank you.
Hello.
Yes, sir.
Okay, Prakhar, nice presentation. But okay, fine. What is SRAM?
SRAM cell is used for memories. It's a digital circuit used in memories.
Okay, so why it differ from other RAM?
It provides faster read access time. There are two kinds of memory, SRAM and DRAM. The DRAM uses capacitor. Instead, the SRAM does not uses a capacitor.
Okay, so what is your research?
My research was about to have how do you reduce the power in SRAM.
So how you have done it?
I mean that what I explained. If you look
In terms of your contribution.
well, we designed, these are the we have designed these cells from ground up, basically. These are novel designs.
Okay, so what about the applications of your research?
Applications, see, this is only for a single cell. But we can also apply this to the array cells, which is primarily used in industries. This is for single SRAM cells, 1 bit data.
Okay, fine. I'm done it. Okay.
Thank you, sir.
Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Sonia Pol with the paper titled Optimizing Injection Molding Process Parameters Using Artificial Intelligence-Based K-Means Clustering, a Simulation Data and Computer-Aided Engineering Approach. Ma'am, if you're ready, then you may go ahead.
Yes.
Yeah.
Hello, ma'am. Good afternoon. Okay, so I'm Sonia Paul, and I'm master student in mechanical engineering with a specialization in CAD/CAM and robotics, and in Father Consecuroris College of Engineering. Okay, so I will begin by sharing. This is my screen visible?
Ma'am, it's currently all black covered. It's not really visible.
Just a second.
Maybe you could try screen sharing again.
Yes. Is it visible?
Yeah, it's visible this way. Yep.
And now?
Yes, it is visible.
Okay. Okay, thank you, ma'am. I'll start now. Yes. So my article title is Optimizing Injection Molding Process Parameters Using Artificial Intelligence-Based K-means Clustering, a Simulation Data, and a Computer-Aided Engineering Approach. So let's begin with my abstract. So my objective is to optimize injection molding process parameters to reduce defects like sink marks, cooling inefficiencies, and volumetric shrinkage. So basically, my the methodology is there are 6 critical parameters analyzed that is mold temperature, melt temperature, coolant temperature, injection pressure limit, pure cooling time, and pressure holding time. So, in the context of injection molding simulation software like SolidWorks, plastic cooling time refers to a total time for a part to cool, while pure cooling time is the time that after packing pressure is released, focusing on the temperature reduction of material inside a mold cavity. So, I have conducted simulations in SolidWorks plastics, and after that, beginning with the data of the simulations, I started to do the K-means clustering via SPSS, so categorizing parameters into 10 clusters according to the domain knowledge. And so what I found is that cluster with moderate mold and melt temperatures, optimal cooling times had minimal defects. And it really goes well with the simulations and the defect minimization. So cluster 3 and 8 as identified as optimal baselines. So ANOVA validated significant differences across clusters. So the impact is that enhances product quality and process efficiency. It supports sustainable manufacturing, like says SDG Goal 9 and SDG Goal 12, which is industry and innovation and infrastructure and responsible consumption and production respectively. And it provides a framework for AI-driven real-time monitoring in manufacturing sectors. So basically, K-means clustering is unsupervised AI technique for pattern discovery and grouping. Uh, so it goes with centroids and updates until the coverages and the application in the manufacturing system. So I was very excited to use the K-means clustering in manufacturing system in the era of AI. So it is like to optimize process parameters to reduce defects. So I used the SolidWorks plastics, that is nothing but the CAE computer aided engineering. So I did the simulations on 100 experimental sets via K-means, and I took care that the initial parameters whichever I'm taking should not repeat. So for that purpose, I use the orthogonal array of L27 array for the 4 times. So it became to be 108 experiments, but I did for 100 experimental set analysis by removing some noises. And so my findings are that identified optimal parameter combinations for defect reduction as well as ANOVA validation confirmed effectiveness. And the impact is data-driven optimization for higher precision, fewer defects, and improved product quality. So in the literature review, I found these papers to be aligned, and this motivated me to go for K-means clustering to optimize my injection molding parameters, which are very crucial and critical to control and to optimize and to maintain to reduce the very, very susceptible and very inevitable defects like sink marks and warpages. That too in the products like PMMA, which is nothing but the acrylic. So it is very transparent material, and we really don't want any kind of sink marks or the warpage. Sink mark is nothing but the imperfections and the impartations of the mold, as well as there are some marks on it, some like bubble like. So we really don't want it because especially the PMMA is used for airplane windows or automotive windows and electronics, electricals, and so on. So we have to maintain the aesthetically as well as it should be defectless in order to qualify in the quality controls. The Torres Alba et al. Developed a new automated method for design of conformal cooling systems based temperature clustering and multi-dimensional discrete models for injection molding. So Zhong et al. 2025 covered the different morphologies induced by injection molding in thermoplastic polymer blends. So Young et al. 2009, he examined all the conventional and new techniques of injection molding of polymers, but he never mentioned the clustering. So I just thought that we can do it. Yes. And My ATL presented an intelligent recommendation system wherein CA simulations, process window, and machine learning will be used in the optimization of injection molding process parameters. This motivated me a lot. And the Park ATL ensured the best product in both energy efficiency and product quality and optimization of injection parameters using CA and the another AI tool, which is evolutionary genetic algorithm. It is. So the problem definition and research gap aligns with the injection molding faces challenges in defect-free production due to complex parameter interactions. Defects such as sink marks, shrinkage, cooling inefficiencies, increased costs and cycle times. Traditional optimization struggles with large data sets and complex interdependencies. The need for an advanced data-driven approach for effective defect mitigation. So research gap is that the CAE plus AI, that is K-means clustering integration, is underexplored in injection molding optimization of their parameters, input as well as output. So existing studies focus separately on CA simulations or AI techniques lacking synergies. So a lack of statistical validation, that is ANOVA for AI-based clustering method, limited real-time parameter optimization using simulation-driven AI models. So the alignment between problem definition and research gap were means consist of complexity of process parameters, limitations of traditional optimizations. These are the aspects which aligns with the interdependence of parameters like mold temperatures, cooling times, pressure is to challenge to optimize, and the integration of CA simulations with AI, such as K-means clustering, is unexplored for handling complex interdependencies. So this both emphasizes the need for advanced tool to address parameter interdependencies effectivity. The limitations of traditional effectiveness. Standalone CA alone cannot do everything like optimization and it can do, but it should be in the system of it. Like we cannot say it cannot do, it can do. Uh, so, uh, According to the resources available, I did the simulations first, and then I then took the data and put it into the SPSS, and then I just got it clustered it down for the optimization. So the data-driven insights are also taken place in this scenario, as well as it is validation and reliability is also there. So I can say that it has robust methods combining multiple variables systematically are required for optimization. Lack of validation for AI models like k-means clustering, using statistical methods like ANOVA to ensure its reliability. So both emphasizes the importance of reliable validation methods for ensuring optimization process. The CA with AI for optimization, it focuses on AI-driven approach to identify and optimize critical process parameters. So the methodology over here is this is nothing but the acrylic sheet, and these are the cooling channels which I have plotted, and this is the injection gate which the plastic is getting into the mold. Yes. So, using Solidworks plastic to simulate injection molding of acrylic sheet 30 by 30 and 3 mm. Like I wanted to use some uh, a easy product just to ensure that if it is going well with the critical parameters. So I have did the 100 simulations conducted to analyze process sensitivity and optimize mold conditions. So injection location, cooling channels, and coolant flow are designed to improve for improved part quality, as well as the fixed factors are mold material, that is beryllium copper, high thermal conductivity, coolant type is coolant L45, efficient heat transfer, and the coolant diameter is 19 mm, pointer is 8.5 mm, and so on. And the varying factors which we are ranges based on the SolidWorks plastic database is melt temperature, which is around 242 to 80 degrees Celsius, mold temperature 35 to 80 degrees Celsius, and so on. Like coolant temperature, injection pressure limit, pressure holding time, and pure cooling time, and so on. And I have done the simulation by taking the um, by matching the temperatures accordingly as per the simulations which the SolidWorks advisor was advising. And so key simulation insights were that moderate melt temperature, improved material flow, reduced warpage, balanced mold temperature can give us the dimensional stability, means there will be no warpage at all, and the lower coolant temperature, more uniform cooling and efficiency, optimal injection pressure, prevents flash defects, pressure holding time, longer time, improved part packing and shape, and the cooling time optimization balances cycle time and defect reduction. So over here, these are the cooling channels. These are
Ma'am,
the conventional cooling channels.
I'm
Yes,
really
ma'am.
sorry to disturb you, but I'd like to remind you of the time limit.
Yes.
Okay.
Okay. Yeah. Thank you. Okay. So K-means clustering analysis and ANOVA validation of the clusters. Okay. So I will directly jump over here. So the optimal clusters were cluster 3, 6, and 8, low defects and stable cycle times, and the yes, and the most influential factors are cooling time and the mold temperature, because we can see it over here. The F factor over here is 48.501, and mold temperature. So this aligns with the with the experience of this 100 simulations I have done. So it goes well with this, and everything is significant. So we have validated it by using the ANOVA. And these are the k-means clustering which we have carried out. So the clusters 3 and cluster 8 can gives us the optimal parameters where there are minimum defects. Here we can see there is 0.032727 sigma, as well as here we can see 0.030856, and the volumetric shrinkage is also drastically reduced, and it is also optimal. Mold temperature is 58 to 75, and so on. So these are the results and discussions that like what clusterings are giving us the insights by observing the things. So the optimal baseline is cluster 3 and cluster 8 identified as the optimal baseline for reduced defects and improved process stability. So here we can see the moderate mold temperature in the cluster 3, moderate mold and melt temperature, reduced volumetric shrinkage, optimal cooling time, and low sink marks, as well as the 8 can also we can see that optimal cooling time, mold temperature combination, low sigma cooling times, and shrinkage. Okay. Okay. So the summary of optimal parameters, key takeaways, and actionable insights are key takeaways are like balanced mold and coolant temperature, medium melt temperature, adequate injection pressure are critical for minimizing defects like sink marks and warpage, while maintaining quality cooling time plays a pivotal role, impacting both sink marks and volumetric shrinkage. Mold temperature is essential for maintaining surface finish and dimensional accuracy. Shortening cooling times reduces production cost but risks increasing defects unless parameters are optimized. So the actionable insights are go for the cluster 3 and cluster 8 for the process improvement. So we can incorporate these findings from simulations to further refine cooling and pressure parameters, ensuring high quality outcomes with reduced cycle times, as well as it is cost effective. So conclusion is like K-means clustering effectively group process parameters, providing clear guidance for optimizing complex interdependencies. Combining CAE with K-means clustering enable real-time optimization. It can be a real-time optimization. So overcoming the limitations of traditional methods, the integration, and the ANOVA validation confirming the reliability of the clustering model, ensuring that the derived insights were statistically sound. So the benefits are here that it improves the injection molding parameters and has a lot of benefits. Defects of sink marks and volumetric shrinkages are no more. And the process efficiency is significantly enhanced by because the time to complete end-to-end cycles is reduced and the number of throughputs increases by the optimum combination of parameters and the optimization means a lot for cost benefits as the minimized wastage of materials and need less of rework for save money. And so the KMS clustering enables database decision with precision so that all the process can be changed at the plant level with scientific insights concerning adjustments to the process. Finally, this gives an innovation of more sustainable manufacturing processes as they lower energy and material wastes. So the sustainable development goals addressed here are the SDG 9 and SDG 12, which is industry innovation infrastructure more specifically. And SDG 12 goes for responsible consumption and production by promoting sustainable production by using the AI. So the future scope is like integration with advanced AI models, expansion to additional quality metrics, real-time monitoring and adaptive control, enhanced industry 4.0 integration. So the managerial implication is the training and development initiatives could also be carried out. So KMS cluster with the managers can vary strategically when optimizing injection molding parameters. We can develop it into a good model as well. So, beside manufacturing processes aligned to sustainability objectives would strengthen corporate social responsibility initiatives in which governments will ultimately comply with environmental regulations. So, optimize process for better managing costs by reduce waste and defects, rates improve energy efficiency, reduces cycle times, and boosts profitability. So, these are the references. And yes, thank you. Okay. Can I stop sharing?
So, would you like to ask any question? We will be proceeding with the next presentation. We once again have Ma'am Sonia with the paper titled Revelation Through Principal Component Analysis, Enhancing Decision Making in Injection Molding Process Parameters Using Simulation Data and Computer-Aided Engineering. Ma'am, you may go ahead. And please be mindful of the time limit. We are running on the time. Yeah.
Yes, ma'am. Sure, I will. I consider it. Yes. Okay. Okay. Hello again. Once again. So my title of the manuscript is Relevation through Principal Component Analysis, Enhancing Decision Making in Injection Molding Process Parameters Using Simulation Data and Computer-Aided Engineering. So, ma'am, it will take only like 5 to 10 minutes to conclude this because I have already mentioned the simulation part of you. So I will just jump for the aim, motivations, and the methodology used.
Sure, ma'am. Sure, ma'am.
Yes. Thank you, ma'am. So my aim is to enhance decision making in injection molding by identifying latent patterns among critical process parameters using simulations and principal component analysis, ultimately improving product quality and reducing defects. The motivation is traditional trial and error tuning lacks precision and waste resources. There is a growing need for data-driven insights that uncover hidden interdependencies between thermal and dynamic variables, enabling smarter, faster, and more reliable process decisions. So, novelty for this is this study uniquely integrates solvers plastics data simulation data with PCA to reveal hidden correlations between thermal and operational factors, and it moves beyond standard parameters to parameter optimization by providing quantitative insights into variance contribution and enabling targeted process control strategies readily addressed in earlier studies. So the literature you hear over is the dynamic, like Kamal ETL has presented the dynamic and control of pressure variations with different points in injection molding process. So ATL and this everything we can see that it has been in the 90s. This method has been used since 90, only in the 19s. I cannot find some new papers on the PCA, which is integrating with the CAE and the manufacturing era. So the smooth application of advanced control strategies, including PCA, to regulate pressure in cooling cycles of an injection molding process. So in major process and so on. And Bank ATL, he integrates CAE systems and process control models to optimize processing conditions. So the problem statement is injection molding demands precise control over multiple thermal and operational parameters to ensure part quality. Despite technological advances, defects like warpage, shrinkage, and sink mass persist, leading to high cost, longer cycles, and poor quality. So trial and error methods are time consuming and efficient. So systematic data integrated approach is needed to identify and prioritize the most critical process parameters for an effective optimization. So the research gap over here is that while tools like SolidWorks Plastic support predictive analysis, um, they often lack integration with advanced statistical methods. So existing studies mostly focus on individual parameters, but they neglect the combined influence of thermal and dynamic factors. So the integration of PCA with simulation for revealing the interparameter relationship is still underexplored. This research bridges the gap by combining simulation with PCA to identify, rank, and optimize the key parameters affecting part quality. So yes, the methodology part, I already told this. So the material is polymethyl methacrylate, which is acrylic. So this I have already discussed. Yes. So this is principal component analysis to analyze the process by different groups with the influence defects in injection molding. So over here, I have used KMO and barrel test results and the total variance explained over here. So the adequacy measures for PCA is extraction method is PCA, rotation method is Varimax with Kaiser normalization, KMO test measure of sampling is 0.631 and which indicates the suitable data for the PCA, and the Bartlett sphericity is 0.00, which is very significant, and correlations between variables are adequate for the PCA, and it shows the variance of component 1 and 2, which is decent variance which we can go for the PCM. So these are the component what I got this component 1 and component 2, which is nothing mole temperature, melt temperature, coolant temperature, and into the one component, and the other represents the pressure limit, injection pressure limit, pure cooling time, and pressure holding time. So these are the things which we can this is the main motto which I have to present, that we can by finding the latent patterns by using the PCA in the data of the injection molding parameters, we can optimize it accordingly. We can use it as a root cause analysis, and we can see how it is influencing, and like strongly, moderately, or if it is not influencing at all, we can go through it. So the component 1 is thermal analysis, mold temperature, it is strong influence, critical for surface finish and dimensional accuracy. Melt temperature is moderate influence, improves flow uniformity and reduces warpage. The coolant temperature is strong influence over here. You can see we can see a matrix over here. See, lower values enhance cooling rate and temperature control. And the negative correlation, high pressure may cause flash defects. So it can also indicate as a strong influence, even if it is giving us the in the minus, because it indicates that it has a negative correlation, and we can integrate this, we can relate this um, with the manufacturing parameter, that is high pressure may cause flash defects, and the pure cooling time, which gives a strong positive correlation, longer time but better surface quality and less defects. But too short is risks of defects like warpages or sink marks. And the pressure holding time moderate positive correlation enhances packing but increase cycle time. So my main motto for this research to bring this research was the integration of solid plastic simulations and principal component analysis, which enhances the injection molding process by optimizing key parameters like mold and melt temperatures, cooling time, and so on. This leads to improved product quality, reduced defects, and more efficient use of resources, minimizing material wastage and energy consumption. So this is the thing which I explained previously. So integration outcome is reduces defects, optimizes material flow, increases part quality, saves time and cost and energy. PCA can work for everything, but you have to have a good data which shows the variances and which can be able to find out the latent patterns of it. So over here it is variance explained over thermal variable is 33.60% for component 1. Key findings are mold, melt, and optimize thermal parameters for mold stability, shrinkage control, so we can control in that way. So total variance is 55.27. So the combined thermal and dynamic factors dominate mold performance, that which focusing on optimization efforts on top contributors identified via PCA. So for the process dynamics is also same as the thermal variables. We just have to improve and adjust the time and pressure parameters. Okay, so it supports clear communication with stakeholders and grant agencies and helps in creating structured decision-making frameworks, outperforms traditional method by being efficient, sustainable, and targeted. It enables data-driven decisions and simplifies complex data. PCS made for that only. So the conclusion is enhanced process efficiency, PCA driven insights, which is thermal variable and process dynamics, validated approach. PCA effectively manages simulation variance, results aligned with experimentally validated results, but it has some minor limitations because of the material models, mesh sizes, the tetrahedral, and there are so many messages are account for in the PCA variance. So it is sustainable and economical, reduce material wastage. We can be able to if we do it in a more efficient way with the big data. And so support eco-friendly and cost-effective production. So the future scope is we can AI ML integration, of course, for the industry 4.0 and 5.0. So the support for sustainable materials, user-friendly simulation interfaces, and multi-material modeling. So simulation adjustment for complex material interactions enables flexible, small batch productions. Visual PCA dashboards for better decision-making, feedback loops for continuous process improvement. If anybody is really interested in this, please try to contact me. I'm very much interested in going ahead with this. Yes, and these are the references. And thank you so very much.
Hello.
Hello.
Yes, Sonia.
Yes, sir.
Can you show me your title, please?
Yes.
Okay, so you have used k-means. Hello.
No, sir. Hello. Yes, sir. I haven't used K-means. I used K-means in my previous presentation, in my previous article. But here I have used principal component analysis.
Okay, so what is PCA?
Well, PCA is like it is used to reduce variables into principal component that explains maximum variances. It normalizes the things and it shows us the latent patterns, the hidden patterns, whichever is in the data, and it groups together so that we can identify that where it is going, like which are the parts and which are which where we can group and cluster that yes, this group is for one purpose, this group is for one purpose. We can identify it by domain knowledge and by identifying and observing the parameters.
Okay, so you know about the PCA. So what about EDA?
What about
EDA.
E
E.
Euclidean distances?
No. It's not an Euclidean distance.
Hmm.
That is a part of the machine learning. Okay, which one
Yes.
part that you have used in terms of PCA. Okay, that
Okay.
is another part. EDA.
Yes. Yes.
That is
Okay, sir. I
exploratory
mentioned
data
it.
analysis.
Can you repeat,
Exploratory
sir?
data.
Okay.
Exploratory
Exploratory
data
data analysis.
analysis. Yeah. So what
Yes.
is the
Yes.
difference
Yes.
between PCA and EDA?
Uh, I'm sorry, sir. I I don't know about it.
Okay.
Mm.
Okay, okay, no issue.
I will make sure,
Fine.
sir, what it is. Yes. Thank you,
Yeah.
sir. Thank you for the new
Okay.
insights.
Yeah.
Yeah.
Okay,
Thank
I'm
you, sir.
done.
Okay, sir.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Abdullah Al-Farabi with the paper titled The Hidden Risks of Cyber Slacking, Analyzing Configurational Patterns, ACP in IS Security. Sir, if you're here, then you may go
Yes,
ahead.
can you hear me?
Yes, sir, you're audible.
Give me a moment. Is it visible?
Yes, sir, the PPT is visible. Please
Great.
turn
Yes.
into
Start.
slideshow mode. Yeah, perfect.
Thank you. Hello everyone. My name is Abdullah Farabi from Bangladesh. This is my title, The Hidden Risk of Cyber Slacking, Analyzing Configuration Patterns in AI Security. So when I'm discussing about the cyber slacking, this basically means that when an employee uses their office internet to go through their social media, like such as personal emails or online shopping or FB or Insta. So the object is that mainly it parts that practices have raised concerns about how they can lead to security flaws. Our investigation shows the specific reasons that result in vulnerabilities like malware infections and data breaches. The report offers practical recommendations for reducing this risk. Then we have also reviewed the social cognitive theory. We found the importance of taking a survey that contained reasons for cyber slacking and recommendations. So we took the survey around 236 responses, allowing us to take into participant opinions and evaluate the data quality through the correlate coefficient and linear regression. And also for the measurement of the quality of the paper, we have also reviewed the 15 literature papers and adding a depth to the research. So these are the few of the researchers that we have found. Like some have encouraged about the technology in their workplace that defies the organizational standards, and also they are hoping for acknowledged about the problem of the cyber loafing or cyber slacking. They have also talked. Then other literature have also talked about the cyber slacking. Maybe it could be really endangered in the business industry as well. So our motivation is to find out the reasons behind the cyber slacking based on analysis of the literature review for the quality measurement of the papers that are good enough to focus on the problem. In addition, we surveyed 236 people, as I've said, and the importance of the SCT theory in assuming employees' opinions. In the survey, we also include a few recommendations if the employees agreed, disagreed, or partially. To check that the survey contains valid reasons and recommendations, we have also added a correlated coefficient and linear regression, which is basically our motivation. So this is the flowchart that from the research from the very first we have given a survey to the employees, like where questions there are questionnaires based on the reasons and also the recommendations. Then we have talked about the social cognitive theory. Then the result analysis we have divided into two parts. Like one is for the quality measurement of the literature review, which I will indicated as the kitchen hum method, and another one is the statistical analysis, which based on two analysis like such as linear regression, correlated coefficient. So these are the reasons, and this is also important part, like where I actually indicate the reasons as R1, R2 to R6. In the result part, I will discuss about it. So these are the reasons that I found the whole literature review and from also taken the survey from the employees, like it causes like the malware virus attacks, or maybe the weakens the security measures. Also, it could harm the private information of the office. Then also cyber criminals can use manipulative strategies to trick employees. So these are the reasons that I have found. And these are the recommendations. And for the recommendations, I have also indicated each recommendation as S1, S2, S3 to S8. So here's the model theory that I have used, the SCT theory, which recognized which actually developed by Albert Bandura, explains the human behavior as a dynamic interaction between personal factors, environment influences, and behavior. So here is the social relationships, which indicates that cyber slacking may become the norm if coworkers use their private social media through the office internet. The self-hypothesis is workers who feel confident in their abilities may think they can handle their work well, even if they occasionally indulge in cyber slacking. And the environment culture is in a workplace where workers do not properly monitor cyber slacking, the conduct might become widespread. And why we have used it? Because we think that while you are using the internet in your office, it is basically based on the human behavior or the organization psychologist perspective. So here's the data collection we have taken. Like I have already told that the reasons we have taken here from R1 to R6, and the 8 recommendations we have indicated them as S1 to S8. So total of, you could say, 8 total of 14 queries that we have given survey to the employees, and their age and we have taken the employees between the age of 28 to 35 because we wanted to take the surveys of the modern era generation employees. So this is the 236 responses we have got so far. And you can also already see that the employees who actually agree that they use internet for their personal social platform are almost 74.6%. So the slide, it indicates the correlate coefficient, where the correlation coefficient is a the real value between -1 plus 2 plus 1. And it also, you can see that the correlation coefficient we have used it because to match the attributes with each other. As you can see, as I mentioned before, the reasons that I have used R1 to R6. Basically here it is indicating the relationship with each other. So here you can see that R1 and R2 reason, which are really correlated of highest value of 0.546. And in the recommendation part, we have used the same thing, like where we also can see that S1 and S2 recommendation, they are correlated with each other, 0.536. And here is the linear regression. When you run a linear regression, the output includes several key statistical values that tells how well your model explains the relationship between your independent value and dependent value. The null hypothesis is basically when it is the significant FP is greater than 0.05, and if it is alternative hypothesis, then its P should be less than 0.05. So here we have used the linear regression for the first figure, because we have introduced the R1, R2, R4, Y5, and R6. Why we have ignored the R2? Because in previous one we have already watched that R1, R2, it's correlated with each other highest number of 0.546. So it's basically we have used it coefficient to ignore those reasons which are so much correlated with each other, like especially R1 and R2 is related. So it's obviously reason that you can choose one of them. So I chose the R1. Same goes for the recommendation that S1 and S2 is the most correlated with each other. So it is good to use only one of the recommendation. So for the data analysis, it is good to analyze with the short version of data. So here is the part, like where the table shows, the first table shows that P is so much less than 0.05. It means the linear regression model is the alternative hypothesis, which also signifies that the linear regression model for R questionnaires is significant. The same goes for the recommendation letter as well. Like where is P P is equal to 0.00014, which is less than 0.05, which means the linear regression model is the alternative hypothesis and signifies that a linear regression model for recommendation is significant. So here's the table that I have used of the kitchen hub B method. So I have used around more than 15 literature reviews, but for the presentation, I have just given few of the examples, like 5 literatures. So P1, P2, P3, which indicates the literatures that I have found, and I have compared with my research. Here is the result, and also the objectives that we have found in the whole about the paper. So here's the thing that we have done is that as I have mentioned that I have used the 6 reasons R1 to R6. Now we tried to compare this with the literatures that we have found. If our reasons matches or signifies that the literature that the literatures are also agreed, and our most of the findings do really carry those literatures or not. Now here's the thing, like if for an example, if we can see the P1 means the previous that we have found the first literature. So here's the thing that our first reason R1, which signifies that it attacks for the cyber slacking, it also attacks the malware virus. So the R1 reason do actually the P1 literature talked about the first reason, and also they also talked about the R2, R3, R4. So the first four reasons that we have mentioned and we have collected, our first literature has also talked about the same reasons. That's why it's accepted. So that's why we have let the value is a equals to 1, which is accepted. If it is not, then like for example R5, the reasons R5 is that is not verified or maybe talked about in the P1. That's why we have ignored that's why we have mentioned the I, which is 0. And if it is partial, then it is R6 equals to M, which means it's partially 0.5. And if it's ignored, then it is 0. So if we can calculate that it's totally of 4.5. So we have mentioned that thus the paper quality has maintained good quality, and also the total score for each literature review is above 3.5. So that's why we have taken around 15 literatures for the quality measurement of our paper and also their paper as well. So the final conclusion, I can say that it's a whole complete package to determine the consequences of cyber slacking, and also we try to focus on the psychology of the employees and the concern about throughout their the internet they use during their work. The limitations is like that we already take only 236. So we want to take more than 1,000. So for the short version of the responses, that's why we have only did the work on the 236 responses and used the Microsoft Excel. And in the future work, we want to use more than 2,000 or 3,000 the data analysis, and also you want to use the Stata tools and more other tools as well, so that we can use another psychology knowledge and also the criminology knowledge on our paper and take more employees responses as well. So thank you. This is my references, and thank you so much for the presentation. And you can, if anything to ask, please ask this.
Hello.
Hello.
Okay. So what is your research perspective?
The main perspective was the concern about the cyber slacking, because many people actually do think that that while using internet in the office, it might not harm harm anything. But rather than this, actually we found that later on that someone like as an employee, whenever he click in a link or maybe go through their social media, sometimes it actually affects the cyber security. So this is basically about the methodology of your concern and your psychology, the thinking of like, do you agree or disagree about the cyber slacking and your concern about the cyber security as well?
Okay. So what about your research contribution? What about the innovation in your research?
Oh, the whole research that first we have taken the whole responses of the employees, like between the age of 27 to 35. So the data we have collected is totally from us. It's a new data, and also we are still collecting info through the survey, and it's basically to check the survey contains valid reasons and recommendations. And also we have used the correlate and linear regression, and also taken the perspective of the employees, that what are the more reasons that you think that it might affect the cyber slacking in the office.
Okay, fine. Okay.
Oh,
Thank you, sir.
thank you. Thank
We'll
you.
be
So, thank
proceeding
you.
with the next paper presenter. I'd like to invite paper presenter Devi Nilema with the paper title Video Transcript Condenser System. Ma'am,
Yes,
if you're
ma'am.
ready, then you may go ahead.
Yes, ma'am.
Yeah.
Is it visible?
Yes, ma'am. It is visible.
Yes. Thank you, ma'am. Good afternoon, everyone. I am Nilima. I am here to present my project Video Transcript Condenser System. Nowadays, YouTube is flooded with educational and informational videos. However, many of them are long and time consuming to watch the entire video. Now, let me start. Many of us are here have bookmarked long YouTube videos, thinking I will watch this later and then never go back to them. Be it a one-hour lecture or a technical tutorial, it's a challenge to sit through the entire thing, especially when you are just looking for the key information from that entire video. And the issue that we have rectified from our end is when we are in college, at the time of examinations period, we used to study from the material that provided by the management. And when we find any difficulties from the materials that they are provided by them, we rapidly shift to YouTube to watch the videos to understand the content from them. But here the issue arises when we have very less time for the examination, and when we are not aware of how much it's going to, and we are not able to sit at a point to listen to the entire video, we just skip it, or we used to watch with the 2x speed. So if for instance, if the video duration is 20 minutes, it hardly takes 40 to 45 minutes to watch the entire video, understand the content, and to pause the video and to make keynotes from that. So this is the issues that we have identified, and our idea is simple: to automatically extract and summarize the key points from a long YouTube video without watching the entire video. We call this video transcript condenser system. The key concepts that the project covers is NLP, natural language processing. This project processes YouTube video transcripts and generate concise summaries. NLP techniques such as text pre-processing, tokenization, stopwords removal, and summarization, these all extract meaningful content from the entire generated transcript. And then coming to summarization techniques, there are two kinds of summarization techniques present here. And the first one is extractive summarization, which selects the most relevant sentences from the transcript generated from that YouTube video. And the next one is abstractive summarization, where it generates new sentences to summarize the content more naturally. It generates new sentences from the summary that is generated by the application. And then coming to API based data retrieval, here there is no any physical data set to store data which is taken. This system uses YouTube's API to fetch transcript from video URL provided by the users. API integration ensures real-time access to video transcripts without manual intervention. There is no need manual intervention to take the data, to store it, to pre-process it. It is completely done by YouTube Transcript API. And then coming to the Streamlit for deployment, this project got deployed into Streamlit, which provides a user-friendly interface where users input a video URL and receive a summarized transcript. And then coming to text pre-processing and storage, the processed transcripts and summaries are displayed in the UI user interface. This system may include caching or database storage for efficiency and retrieval of previous summaries. The raw transcript often the contain things like filler words, timestamps. All these are irrelevant speaker chatter is removed from that pre-processing pipeline, so that it cleans the text. We remove the noise and correct formatting to get transcript ready for the summarization. And these techniques like extractive summarization, which identifies most important sentences in the text and stitching them together into a readable summary, just like a highlighter going through a document and picking out the most relevant lines. And then coming to the architecture, the user gives the YouTube video URL, which contains YouTube video ID, and then it fetches the transcript. If the video already generates automatic transcript, it fetches the transcript, and the NLP techniques gets make the pre-process things done, right? Like text cleaning, uh, uh, and also stopwords removal and all. And then coming to sentence segmentation, based on the rank term frequency and inverse document frequency, the sentences gets ranked, so that the mainly focus sentences get down into the summary that is generated by the application. And then that summary can be generated like bullet points, key points, by highlighting some of the words that entered by the user, and this is generated by the UI. And then coming to the technical details, programming language used is Python for backend processing, and for the user interface, Streamlit Web Framework is used. And then coming to the APIs and libraries used, YouTube Data API, which fetches transcript. YouTube Transcript API is used, and NLTK for text pre-processing and NLP operation. And then coming to development environment, VS Code is taken, and Streamlit for deployment. Now coming to implementation details, the technology stack we used is Python, and then the input module. There are 5 modules in the implementation segment. The video link submission. Users enter a video link as input in the user interface. By using YouTube API, the transcript of the video is fetched. If the video has no captions, then the user is notified that an error message is found on the page that the YouTube video does not contain subtitles. And then coming to pre-processing module, text cleaning. After cleaning the transcript, it removes metadata like timestamps and irrelevant noise in the video and irrelevant data. This ensures that transcript is suitable for analysis. Next, coming to tokenization, the cleaned text is divided into tokens that are sentences and words. Tokenization is useful for extracting meaningful content for efficient processing. And then coming to stop words removal, non-informative words like this, that these all words are eliminated from the summary generated, which ensures that noise is reduced in the data and analysis is very easy. And then coming to summarization module, sentence scoring using term frequency and inverse document frequency. Each sentence is given a score based on the frequency of terms, how many times the word is got repeated in the transcript. Sentences with higher scores are more likely to be present in the generated summary. The high frequency words got generated from the transcript into the summary. And then coming to the extractive summarization, the word itself defines extractive. It extracts based upon the scores. The system selects and extracts the most important sentences that is present in the video. Less important or redundant information is eliminated. And then coming to summary generation, the selected sentences are arranged in an order so that logical flow is maintained. Summary that is meaningful so that without losing the essence of the video. And then coming to the output module, customization. Users can specify the length of the summary and keywords to get highlighted in the summary. For suppose the YouTube duration is 20 minutes, and when user selects length as short, that that particular summary can be generated from 100 to 150 words, and users can also customize length like short, medium, and long. Summary display. The summary is presented in bullet point format with highlighted keywords by the user, which make user to understand the data easily. Next, coming to polarity analysis, the sentiment of the summary is determined using NLP libraries. Next, text-to-speech integration. The summary can be read aloud and the playback speed is adjustable. And the summary which is generated by the application can be available as audio file and also a PDF file, which makes easy for the user to read and understand in the offline also. The summary can be downloaded as PDF, and also audio file of the summary can also be downloaded. And then lastly, user interface. This system is built using Streamlit, which provides an interactive web-based interface. Users can input video links and download the summary according to their need. We also developed our solution using Streamlit so that it's a clean and simple web application. We just paste a YouTube link, hit summarize, and you get the key points instantly. No installation is required, no technology priorly required. In terms of technical tools, we used Python for scripting. One major advantage of the system is that it's domain independent. Whether it's an educational video, a product review, or a business talk, our system works the same. For students, this can help and to revise lectures faster. For professionals, it saves time going through technical webinars, and for content creators, it can ever generate automatic summaries for their viewers. And then coming to project integration, API handling ensures seamless integration with YouTube API for transcript retrieval. And then module coordination, pre-processing, summarization, and user interface modules must interact efficiently, which provides data flow between input, processing, and output modules. And then coming to file management, efficient storage and retrieval of generated summaries like PDF files, audio files, which avoids duplicate downloads and also improve user interface and experience. And then coming to scalability, which allows concurrent processing of multiple videos without performance issues. And the generated summary gives you the different concised summary of different videos. The input link takes multiple videos at a time, and the summary is generated separately, and the download will be done separately for each and every video. And then coming to test cases verification. Here is the test case verification where its purpose is to ensure the system works as intended across different scenarios. uh, some of the test cases is we ensured the system extracts accurate transcripts for valid YouTube links, which handle scenarios with invalid or unavailable transcripts seamlessly. And then generated summaries that adhere to the chosen length, like short, medium, or long, dynamically adjusted the prompt to match the word count requirements. Here we have integrated prompt engineering so that user can prompt the length like short, medium, long, so that the
Ma'am,
summary can be adjusted. Yes,
I'm
yes,
really
ma'am.
sorry to disturb you, but I'd like to remind you of the time limit.
Yes, okay, ma'am.
Yeah.
And then there are processed multiple video YouTube links efficiently in one go, which delivers accurate summaries and outputs for each video link. And the last one is it ensures the system can process videos of various duration smoothly without lag and performance issues. And these are all the uh, images of user interface which appears on the application of the system. And this is the summary of notes which is generated, and this shows the sentiment analysis, the polarity. And this is the audio file, and these are all the time taken for the video with the different lengths chosen by the user. To conclude, a project saves time, promotes focused learning, and makes consuming video content much smarter. It's simple, practical, and something we genuinely wish existed during our own studies. And the future scope comes here where we wanted to make it multi-language support. Here the system limits up to only English, and we wanted to use language models to generate summary in different languages. And then coming to recommendation system, based upon the summary generated, videos can be recommended to the user, which helps him discover relevant and valuable content. And then coming to mobile application, a mobile app would make it more accessible and user friendly, so we try to make allowing users to summarize videos on without needing a desktop or web interface. And these are all the references we have worked on for this project. And yeah, thank you. I'm here to take your questions.
Okay, Nilima,
Yes, sir.
what is bag of word?
Sorry, sir. What is?
What is bag of word? As you have written or told us, like bag of word is there, so that we have to remove.
Okay, sir. It is usually wide technique in NLP, sir. It is used to represent textual data, sir. Like a sentence or a paragraph as just a collection of words. I think so.
Okay, what is TF-IDF?
It's term frequency and inverse document frequency, sir. It is technique in one of the techniques in NLP. It uses frequency, how frequently the word is the word got it gets ranking. The majorly the frequently used word will get generated in the summary that is provided by the application, sir.
Okay, fine, done.
Yeah, thank you so much, sir.
Yeah.
Thank you, sir. Thank you, ma'am. We'll be
Thank you.
proceeding with our last paper presenter for the session. I'd like to invite H.T. Vasudeva with the paper titled Forecasting Future Water Requirements and Assessing Storage Capacities in Reservoirs. Sir, if you're ready, then you may go ahead.
Sure. Greetings. Am I audible?
Yes, sir, you're audible.
Yeah. I'll be just sharing the screen.
Sure, sir.
Hope it is visible.
Yes, sir, it is visible.
Okay, I'll put it in presentation. Okay. Yeah. Greetings to everyone present here, the panels as well as the thanks for the host. This content for today's paper, that is 422, is forecasting future water requirements and assessing storage capacities in reservoirs. So this specifically is an application-based research that we have done. And as you can see, this is presented by me, H.G. Vasudeva, along with other co-authors who have contributed to this paper. So without further ado, let us go to the introduction. So here we are going to just assess how water is really important in our life. And it is very important to conserve water in real time. So here in this paper, we are accurately forecasting and assessing the capacity of water in various waters, that is reservoirs, groundwater level, and various such. This also ensures adequate supply for domestic, industrial, and agricultural sectors. So as we know, the reservoir water level and the groundwater level, how much it is there. So according to that, we can supply water to these sectors, that is domestic, industrial, and agricultural. So we have also used machine learning models like linear regression as well as random forest to predict water levels. And next, these models also give quite insights onto various factors that impact water availability. So next, let us go to the objectives of our research. First is to predict future water needs accurately. Second is to assess reservoir storage effectively. Third is managing water resource with the current trend artificial intelligence and machine learning, as well as assisting decision makers with real-time data, as well as provide simulations for better planning. So here is a short prototype of how the phases of our project goes. So here there is water supply mapping, that this analyzes the water reservoir connections as well as groundwater levels to assess how much storage is there and how much storage can be predicted in the future. Later, water usage forecasting, that is predicting demands and using machine learning. Next is sectoral analysis. We have focused on three main sectors that will be coming into the next part. Next is the strategic allocation, that to allocate this water to certain sectors. Next, let us go on to the methodology, that is the data processing. So the first data processing is done to ensure consistency as well as remove the outliers. So numeric columns were resampled to compute daily averages of water usage. Then missing data was managed using forward filling and mean manipulation. Next is Z-score filtering to eliminate the extreme values, that is the outliers. Next is the min-max scaling, a normalized variable that helps in feature extraction and feature measurements. So these data sets were taken in real time from the various government sources that gives us the water level, and we have augmented in reflection with the real-time cumulative countries water need for a year, that is on 2023. And here in the right side, you can see the architecture of how the phases goes on. So first is mapping water supply to the resources. Next is the district-wise collection of the water. That is this agricultural water usage, the sectoral or the industrial water usage, as well as the domestic water usage. So these are the three sectors that we have divided: agricultural, industrial, as well as the domestic. Domestic and industrial, we have taken it as in general terms. And next is also, we have also taken features from climate, that is evapotranspiration rate as well as rainfall precipitation. And in domestic, we have also taken features like population, pre-logs, and all those. Next, from there, it goes on to the model, that is the time series predictive model, as well as the multi-regression model that will come in the next few slides. From there, it goes on to the depth analysis of all what the results of the model has given us. And finally, it is going to strategically allocate water to these sectors. We'll come back to that as to why it is being used. Next, we'll start with the time series forecasting. So once we have the data set of the agricultural water usage, the domestic as well as the industrial water usage, we come to the fact that we can try to forecast the water level of the reservoirs, that how much initially we take the total capacity in the reservoir, which is calculated by MLD, that is megaliters per day. So hence we start forecasting. So initially we take the data set from Jan to December, and we divide it into certain chunks. And in single chunk, we start training and predicting the for next 30 days. So here we have used a model called as SARIMA, that is seasonal ARIMA model. So ARIMA is an auto-regressive integrated moving average model that helps us to assess how the upper limit and the lower limit, and finally gets to know the final forecasting value. So this Sarima model has forecasted the water requirement for the next 30 days after assessing and training for the 3 months, that is January, February, and March. So the predictions are reliable for 95% of confidence interval. And further on, we are using models like linear regression as well as random forest to predict the water levels based on multiple features, hence multi-regression model as well as multi-random forest regression.
Hello.
An optimization model was developed using mixed
Hello.
integer programming. Yes.
Hello. Sorry to interrupt you, but just
Yeah.
focus on your research or your contribution.
Sure,
Fine.
sure. Yeah.
Yes, please. And please conclude your presentation in 5 minutes.
Sure. Done. Thanks.
Yeah.
To allocate water equitably. And the research focuses on certain terms as to how water is being used, and our contribution to the society focuses on the future water prediction as well as the dividing of water into certain sectors. So here are some of the results that we have taken, that is the linear regression as well as the random forest. So we have initiated both these models, and we have shown that the random forest has been more prehensive in calculating the means. We can see R square as well as the mean squared error as well as the root mean square error, which is less as compared to the linear regression. And next we from here, what happens is the forecasted value helps us to decipher the next forecasting level, and the linear regression and the random forest helps us to verify the fact that, okay, at this day, this much water has been taken, and it is verifying the fact that this much water has been used by the Sarima. So the optimization model also provides the next, that is the water allocation optimization as well as the EDA insights, that is the exploratory data analysis. So here we have used the MIP, that is a mixed integer programming, to divide it into agricultural, industry, as well as the domestic aspects. And here we can see that the water has been distributed according to certain linear programming formulas. And hence, this will help us to know which sector needs to use how much of water. So these are few of the references that we have used. And here is the conclusion. That is, finally, we have tackled how to forecast water resources by assessing the resource storage by the data sets that we have acquired. And we developed a robust framework which helps us to predict the water levels as well as allocate certain resources to various sectors. So Sarima model has proved to be a reliable source to forecast the water. The machine learning models like the random forest as well as the linear regression helps to show how much that day water is being used and compared to the future values. The optimization model, that is the mixed integer programming, helps to allocate the water that is left over to help to conserve for future requirement. And finally, the exploratory data analysis and visualizations help the users and the decision makers to take certain decisions, which later will be used, various chatbots that can be used to do it. So that is the end of the presentation. Thank you very much.
Okay, fine. So how many algorithms that you have used? Hello.
We have specifically used 3 algorithms. One is the Sarima model. Next, we have used the linear regression to compare it with random forest. We have also used LSTM, but we have to show that random forest actually in this scenario has enhanced the process in real time and has given non-linearity also to it. So that, and then the MIP model, that is the mixed integer programming, which helps to allocate the water to the 3 sectors that I have mentioned.
Okay, so why you have not used the XGBoost algorithm, extra tree classifier?
Okay, so the XGBoost, that is the ensemble model, will actually
Yeah.
help to boost the optimization, but this is the initial resource where we focused on how to forecast the decisions by Sarima and verifying by random forest as well as division through MIP. So we are focused on this. Further optimization can be done through XGBoost, but we have thought that we would focus on how to allocate water and the result, the water footprints that is taken by each sector.
Mhm. Okay, good, fine. I'm done.
Yeah, thank you very much, sir.
Thank you, sir. This brings us to the end of the session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version 2026. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I'd also like to thank our session chairs for chairing the session. Just a second. A token to the chair on behalf of Team ICTIS 2025 and Global Knowledge Research Foundation. Thank you so much, sir. And ma'am.
Thank you.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, sir. Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.
Thank you.
Thank you, sir.
Thank you.